sklearn, cluster, dbscan. Description: dbscan density-based spatial clustering of applications with noise is an unsupervised learning algorithm that identifies clusters of high density in data. It works by grouping together data points that are closely packed together, while ignoring points that are sparsely distributed. Inputs: X. This is the input data. Typically a 2D array where each row represents a data point and each column represents a feature. Apes. This parameter specifies the radius of the neighborhood to consider when searching for dense regions. Points within this radius are considered neighbors. Minsamples. This parameter specifies the minimum number of points required to form a core point. A core point is a data point that has at least this many neighbors within the specified radius. Outputs: Labels. This is a 1D array that assigns each data point to a cluster. Points belonging to the same cluster have the same label. Points with label -1 are considered noise points. Core sample indices. This is a 1D array that contains the indices of the core samples points that are part of a cluster. Steps: Initialization. The algorithm starts by selecting a random data point and marking it as visited. Neighbor search. It then searches for all data points within the specified radius 8 of a selected point. Core point check. If the selected point has at least minsamples neighbors, it is marked as a core point. Cluster expansion. The algorithm then recursively expands the cluster by considering all neighbors of the core point and their neighbors, as long as they are within the specified radius and have at least minsamples neighbors. Noise handling. Any data point that is not assigned to a cluster during this process is considered noise. Metrics: Silhouette score measures the similarity of each data point to its own cluster compared to other clusters. Kalinski-Haraba's index measures the ratio of between cluster variance to within cluster variance. Visualization plots: Scatter plot can be used to visualize the clusters identified by dbscan, with different colors representing different clusters. Density plot can be used to visualize the density of data points in the feature space, highlighting dense regions where clusters are likely to be found. Fine-tune parameters: Apes. Increasing apes increases the size of the neighborhood and may lead to larger clusters, while decreasing apes may lead to smaller, more precise clusters. Minsamples. Increasing minsamples increases the density requirement for a point to be considered a core point, resulting in fewer, more distinct clusters. Decreasing minsamples may lead to more clusters, some of which may be less distinct. Uncertainty methods: Bootstrapping. Repeatedly resampling the data and running dbscan on each resampled dataset to estimate the variability of the cluster assignments. Sensitivity analysis. Varying the input parameters apes minsamples to assess the impact on the cluster results. Challenges and fixes: Challenge 1: Sensitivity to parameter values. dbscan's performance can be sensitive to the choice of apes and minsamples. Incorrect values can lead to either merging clusters or splitting clusters that should be together. Sample use case that resulted in challenge 1: When clustering a dataset with two overlapping clusters, setting apes too small might result in splitting the clusters into multiple smaller clusters. On the other hand, setting apes too large might merge the two clusters into one. Fixes to challenge 1: Use a grid search or other optimization methods to find optimal values for apes and minsamples based on the specific dataset. Consider using a visualization tool to examine the data and get a sense of appropriate values for these parameters. Challenge 2: Difficulty handling uneven density. dbscan can struggle to cluster datasets with uneven densities. where some areas have much higher concentrations of points than others. Sample use case that resulted in challenge 2 clustering a dataset where a small, dense cluster exists within a large, sparse region might lead to the small cluster being missed. Fixes to challenge 2. Pre-process the data to normalize densities or consider using a different clustering algorithm that is better suited for uneven densities. Experiment with different values of apes to adjust the neighborhood size and account for different density levels.